Assalamu alaikum. Today we are going to understand a simple AVR assembly program used in microcontrollers such as Atmega 32 or Atmega 16. This program reads the input from pin B2 and either display Y or N on port D depending upon the input condition. Now let's come toward the main program. The first line CBI means clear bit in IO register. Like DDRB controls the direction of port B pins. As we all know, 0 is input and 1 shows output. This instruction clears bit 2 of DDRB. So pin B2 becomes an input pin. Moving toward the second line, pin B2 becomes an input pin, and LDI means load immediate. It also loads the value of 0xFF register into R16. Line 3 out the DDRD R16. This sends the value of R16 to DDRD. Result इसका ये होता है कि like all pins of port D becomes output. So then comes the main loop. Again, this is a label. The program will keep returning here, creating an infinite loop. Now next, checking the input. SBAS means skip if bit in IO register is set. This checks bit pair 2 of pin B. Two possibilities like PB2 is equal to 1, skip next instruction, and pin B2 is equal to 0. If 0, execute next instruction. Jump instruction jump means relative jump. If PB2 is equal to 0, the program jumps to over, and if PB2 is equal to 1, LDI, the LDI R16Y, and output port D R16. This program loads ASCII value of Y into R16 and outputs it to port D. So port D will display Y. Repeat the loop again and again. The program goes back to check PB2 again. If PB2 is equal to 0, then if the input is 0, the program outputs N to port D. Program logic. Basically, the program logic continues the check PB2. If input PB2 is 1, then output on port D is Y. And if PB2 is equal to 0, then output on port D is equal to N. Basically, so in this program, we learned how an AVR microcontroller reads an input pin and produces an output using assembly instructions like CBI, LDI, SBIS, and RJMP. This is a basic example of input monitoring and output control in embedded system. Moving towards the Proteus of this code. So in the simulation created in Proteus, we are using an Atmega 32 microcontroller. The circuit reads an input from pin PB2 using a push button and then displays the desired output like Y or N through LEDs connected to port D depending on the button state. So search Atmega 32 and you will get the Atmega microcontroller, and then also after it also add resistor, capacitor, and the desired LED active or inactive as you wish. And then the main component in the circuit is Atmega 32. It has several ports: port A, port B, port C, port D. And in this project, PB2 is input like push button, and port D is an output showing LEDs. And the reset circuit on the left side, you can see our 9 10 kilo ohm resistor connected to the reset pin. Its purpose basically, this resistor is called a pull-up resistor. It keeps the reset pin in a logic high plus 5 voltage, so the microcontroller runs normally. If resets become low, the microcontroller restart, and the push button is connected to pin PB2. Its working is like one side is ground and other side is PB2. When pressed, PB2 is equal to low, and when released, PB2 is high. This input is checked in the program using the instruction output LEDs on port D. On the right side, you can see LEDs connected to port D pins. Pin use PDO, PD1, PD2, PD3, and PD4 till PD7. These LEDs represents the ASCII pattern of characters. The components R1 is used because of protecting LEDs from excess current, ensure safe current flow from the microcontroller. Without these resistors, LED could burn or damage the microcontroller. And the capacitor, you can see C1 is of 0.1 microfarad capacitor connected between AREF ground. Purpose इसका basically है noise filtering, stabilizing the reference voltage from the ADC. Let me conclude this. Simply, we can say that whenever the push button is pressed, the microcontroller detects the low signals at PV2 and the outputs the ASCII value of n through port D. When the button is released, it outputs via the LEDs show the binary representation of these characters. After writing the program in AVR assembly or C, the code must be compiled using software such as Microchip Studio or Atmos Studio. When the program is compiled successfully, the compiler generates a hex file which contains the machine code that the microcontroller can execute. In the Proteus simulation, you then open the properties of the Atmega 32 and simply upload this file in the program file section. Once the hex file is loaded and the simulation is started, the microcontroller runs the program exactly as it is on real hardware along the circuit in Proteus to operate according to the written code. That's it. Thank you.